Hi, it's Mr. Arbizu again today. We're going to talk about section 3.4 of the Math Skills Practice book. Again, it's section 3.4. What are we doing? It says that we're going to combine some linear equations. They give us a whole bunch of word problems. Are they hard? No. I could read English. I could read French and Italian and Spanish, and I'm working on Swahili. Let's get this done. Okay, so for these problem sets, it says that we're going to write a linear function in two different ways to represent each problem situation. I'm going to do number 2. If you get kind of messed up on what I'm doing, go ahead and take a look at number 1. They kind of explain it in 1 or 2 steps. That's not too bad. Hopefully I do a better job. They don't explain themselves. Luckily, I have a voice. Let me see. Number 2, I got to rewrite this scenario in 2 different ways. Isabel makes and sells fruit pies at her bakery for $12.99. Each month she gives away 4 pies as samples. Write a linear function that represents the total amount that she earns, taking into account the number of pies that she gives away. All right. Well, how many pies does she make? I don't know. I'm going to call that X. So she makes X pies, but she doesn't sell X pies because she gives away 4. So the total number of pies that she is selling is X take away 4. She's selling this much. Now, how much is she selling each one for? That's $12.99. So this is one way to write the function. F of x equals 12.99 times x minus 4. How do we rewrite this in another way? Well, we're going to distribute. That's a fancy word for multiplication. I have to take $12.99 and multiply it both to x and to negative 4. So I'm going to take this number and multiply it by this. What's 12.99 times x? It's 12.99 times x. What's 12.99? I got to multiply that by my other term, by negative 4. What is that? Let me see. I know that 13 times 4, what's 13 times 4? That's 52. But that I don't have 13 times 4. I have 12.99 times 4. But if I know 13 times 4, and that's 52, all I got to do is take away 4 pennies from 52. So that's $49.96. Check with your calculators. This is called number sense. I know my numbers. Man, I got 13 times 4. That's 40 and 12. Yeah, 52. Wait a minute. That's wrong, dude. It's, let's go back. I had f of x equals 12.99x. 13 times 4 is 52. I got to subtract 4 cents from 52. That's $51.96. That feels better. You guys got to be comfortable with that. We as mathematicians, we make mistakes. So what do? Do we sit there and cry? No. We go back and we use not only number sense, we use common sense to make sure that our answers are normal. And it's okay if you make a mistake, but have the tenacity and resolve to go back and verify if your results make sense. Let's go on to number 3. It says, Maddie sells heads of lettuce for $1.99, each from a roadside farmer's market, blah, 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 blah. Each week she loses 2 heads due to spoilage. What does that mean? They rot. Either maybe I don't know, it rots. Write a linear function that represents the total. Oh, so this is similar to the other one. So in this situation, let me see, it's f of x. How much lettuce does she actually sell? We don't know. We're going to call that x. But this isn't really all that she sells. She loses 2 of them. So this is how much she actually sells. She had x, but she lost 2. So she's actually selling x minus 2 heads of lettuce. How much is she selling each one for? $1.99. So this is one way to write the function. Another way to write it, if we take this stuff and just distribute, I'm going to take 1.99 times x. That's 1.99x. And then I'm going to take 1.99 and multiply it by negative 2. A positive times a negative is a negative. This is going to end up being 3.98. Let me see. If this were 2 times 2 is 4, but I subtract away not 1 penny, 2 pennies. Yep, that's right. So this is the other version that we like. So both of these are answers. They wanted 2 ways to represent it. I got it. 1.99 multiplied by the quantity, x minus 2. And then I got 1.99x minus 3.98. How did I get that? I took this function and I wrote the right-hand side. I rewrote it by distributing and I got this. We got 2 more problems. This stuff isn't that bad. Let's take a look at problem number 8. Now there's a lot of words here. What they want me to do is write a linear function to represent each problem situation. So this is what they want. I'm going to start reading right here. Now I'm going to start from the top. A pretzel manufacturer has 2 production lines. Line A produces a variety of pretzels that is sold for $2.40. Line A produces 3 bags per day that do not meet the company's standards. What standards? I don't know. Maybe the pretzels kind of break, or maybe, I don't know. Who knows what happens at these pretzel factories. Line B produces a variety of pretzels that is sold for $3.60 per bag. Maybe higher quality pretzels. But 4 bags don't meet the company's standard. Line A produces 3 times as many bags as line B? What? Oh, well, let me see. The linear function a of x equals 2.4 times x minus 3. This represents the amount of stuff that line A produces. B of x equals 3.6 multiplied by x minus 4. That represents the total number of bags each line can produce, taking into account the bags that don't meet the company standards and cannot be combined. Write a linear function that represents the total number of bags the lines can produce combined. I'm kind of confused by this. It says line A produces 3 times as many bags as line B. If this represents the amount that line A produces, and this represents the amount that line B produces, this already takes into consideration the 3 times, so I don't need that. If they want to know the total, dudes, this is easy. All I got to do is take A of x and add to it B of x, because that's a total of something if you take something plus something. So this is going to be some new function. We'll call it T of x, the total. So let me see, T of x. What the heck is A of x? A of x is 2.4 multiplied by x minus 3 plus B of x. What is B of x? That's this junk. 3.6 multiplied by x minus 4. Now this is perfectly fine. It says write a linear function that represents a total. This is a linear function, but it may not look like it to the naked eye. So what are we going to do? Just like in the previous problems, we're going to distribute, and then we're going to collect like terms. So the first thing I'm going to do is distribute. Again, that's another word for multiplication. So I'm going to start by taking 2.4 and multiplying it to these two. That'll be 2.4x minus, oh man, I'm going to fail right here. What's 25 times 3 is 75, it's 7.2? Yeah, Mr. Pabani's a math beast too. He helped me out. Man, let's see if you could do, Mr. Pabani, what's 3.6 times 4? Hold on, let me see if I could do that. So I'm going to take 3.6 and multiply by x. That's 3.6x. What's 3 times 4? That's 12. What's 60 cents times 4? That's $2.40. $2.40 and 12 bucks? That's $14.40? 12 and, yep, 40 cents. So now we're going to collect like terms. What are my like terms? I got 2.4 of these x's and 3.6 of these x's. Because they're on the same side, I just add them together. 2.4 and 3.6, that's 6x, or 6.0x. And now I got this negative 7.2 and this negative 4.4. They're constants. I need to add them together. So let me see. The 2 and the 4 is 6. They're both negative. The 7 and the 4, that's 1. Carry a 1. I got this. So my answer, T of x equals 6 times x minus 21.6. This is my answer. What I do? I wrote the function, I substituted, I distributed, and then I combined like terms. Almost done. We got problem number 9. Let me scoot the paper up. Solid. That's not my word. That's stole or tasty. I don't know what he says, man, but I like it. Okay, Carlos has a roadside stand that sells peaches. He sells peaches for $1.99. He loses 5 pounds. Okay, Hector also sells peaches. He sells his peaches for $2.49 a pound, but he loses a pound. So these functions represent Carlos and hectare. They represent the total amount each stand can earn, taking into account the peaches lost to spoilage. Again, it says all this extra information, but you don't really need this. This is called extraneous. Why is it extraneous? These fools is extra. They're doing too much. We don't need that. This is what we need. We want to write a new function. I'm going to call it the total that they're selling is C of X, that's Carlos, plus H of X. This is Hector's function. So if I replace C of X and H of X with their corresponding expressions, I get 1.99 multiplied by X minus 5. This is Carlos plus Hector, which is 2.49 multiplied by X minus 1. That's step number 1. Then I do what? Distribute. So I'm going to multiply this times this and this times this. 1.99 times X, that's 1.99X. Let me see, this is close to 2. 2 times 5 is like 10, but I got to subtract 5 pennies. So that's going to be 9.95. Okay. And then I got to distribute this stuff. So 2.49 times X, that's positive 2.49X. 2.49 times negative 1. 2, that's just 2 point, wait a minute, I forgot the X. 2.49 times negative 1, that's negative 2.49. So let me see. I distributed, now I got to combine like terms. I forgot to write this T of X here. It can't just be equal to nothing. It's got to be equal to something. So let me see. I got to take 1.99 and add to that 2.49. Why these? Well, they both involve X, so they're like terms. I'm going to cheat. I'm going to pretend that this is like $2 and this is like $2.50. $2 and $2.50 is $4.50, but I got to take away 2 pennies. So $4.50 take away 2 is like $4.48 times X. Now I'm going to do something similar here. This is like close to negative 10, and this is close to negative 250. So let me see. Negative 10 and negative 250, that's negative 1250. I have a feeling I'm going to mess up my math. I got to take away 6 cents from negative 1250. That's negative 12. I'm taking away 6 cents, so that's 0.44. Let me check that. I'm going to do this a little bit different. I'm going to take 9.95. I know it's negative, and I know that this guy's negative, so I got to add them together and know that the end result is going to be negative. So I already did that. Let's check my work. I'm going to add these together. 5 and 9 is 14, carry a 1. These guys add up to 14, carry a 1. Yeah, 10, 12. Hey, man, I got it right. Tasty. That's it.
Done?
Yep.